In the mid-60s, a unique partnership was formed in the world of motor racing. Keith Duckworth, co-founder of the then little-known Cosworth Engineering, joined with Ford in a development that was to change the face of Formula One Grand Prix racing for years. The project, a new power unit, designed to challenge and ultimately destined to dominate this pinnacle of the sport. From the moment it first appeared, the Ford Cosworth V8 engine served notice of its potential. It won its first Grand Prix in the middle of 1967, and then powered Graham Hill and Lotus to the World Drivers' and Manufacturers' Championships the following year. In the next 16 years, 155 Grand Prix were won by cars using this engine. But the name Ford Cosworth is not merely synonymous with Formula One. The power unit that has turned the Sierra into a formidable force on the racetracks of Europe and on the international rally scene is another product of this partnership. And this same engine fitted to the road-going Sierra Cosworth 4x4 now offers any motorist the chance to own a car with a proven competition record for use in their everyday motoring. This long association between Ford and Cosworth has led to the British-based firm establishing themselves as leaders in the field of engine development. And it's an association that is by no means over. For the past 3 years, they've been working together again on yet another high-performance road engine, this time for Ford's Scorpio. Developing a robust 195 brake horsepower, this new power unit is a 24-valve, 2.9-litre V6 that combines silky smooth power with docility and economy. As with all Ford Cosworth developments, the detailed design of this new V6 is both innovative and advanced. The engine block, while based on Ford's current V6 unit, has been substantially reinforced near the main bearings. The crankshaft is new, being both strong to cope with the power of the engine and having had particular attention paid to the centre counterweight to ensure refined smoothness. New graphite-coated pistons have been designed with 4 bowls in the piston crowns and short piston pins. There's the familiar high-performance oil pump, but with its drive fitted where the distributor normally sits on the conventional V6. The aluminium cylinder heads are completely new. They're based on established 4-valve technology, each accommodating 2 camshafts and 12 valves with their associated springs and hydraulic valve tappets. The camshafts are driven by a 2.2-metre long endless duplex chain that locates on double sprocket wheels on each camshaft. There's a new fuel distribution rail serving the fuel injectors on what is a banked multi-point injection system. The sophisticated design of the air plenum chamber not only provides for a precise distribution of air to the engine, it also fully complements the overall appearance of this new V6 unit. Engine management is handled by a new extended-capacity EEC4 module, and this new Ford Cosworth V6 is fitted with a distributorless ignition system known as eDIS-6, identical in its operation to the established eDIS-4. All in all, a most exciting power unit that adds a new dimension to Scorpio, and to reap maximally notable changes in other areas of the car. The proven A4LD automatic transmission has been modified to handle the increased engine power. Inside the car, this smooth-running V6 is quietened further by the addition of new low-noise level sound packs. Suspension has been considerably changed, with uprated springs and shock absorbers and substantial new anti-roll bars at front and rear. The result is sure-footed road holding of the highest class. This is complemented by an uprated braking system, and there's a highly effective limited slip differential to help control the transmission of power to the road, so ensuring this new Ford Cosworth engine can be used to best effect. Innovative and highly advanced, this new Scorpio Cosworth successfully combines a wealth of racing technology in a package that is ideally suited to the motoring needs of today. Even its service requirement demands nothing beyond the scope of a Ford-trained mechanic, with just 3 new special tools to be used during any necessary repair work. It could be said, the Ford Cosworth story continues. Any new engine will inevitably demand some new procedures to be followed in the workshop for both routine service and any necessary repair. In the next 3 sections of this program, we'll deal with how to dismantle and assemble the unit for repair, take a look at the fuel, ignition and engine management systems, and cover some routine service and diagnostic points. Some dismantling of this new V6 can be done easily enough with the engine still in the car. Items such as the air plenum chamber, the fuel injection system, but it's considerably easier to work on the rest of the engine while it's mounted in a stand. Just a small example of this is the routing of the water hose between the thermostat and the water pump. It's located in a passage between the left-hand cylinder head and the block. It's secured by Jubilee clips at either end, and were the engine in a car, it would be awkward to remove. While it's not suggested that an engine be removed merely to replace this hose, the engine's tight fit under the bonnet of the Scorpio will make major repair work, if it's necessary, much easier to handle in a stand. You'll find that the thermostat housing is a new design. An unusual feature is the connection to the left-hand cylinder head, which is by means of a small spacer tube fitted with O-rings. The connection to the right-hand head is more conventional. You'll find nothing new in removing other ancillaries from the engine, items such as the exhaust manifolds, the heat shields, the oil dipstick and tube, and both oil return pipes running between the heads and the oil pan. If you're working towards the removal of the cylinder heads, you'll need to take off the small covers to the 2 chain guide bolts, and also the lifting eye on the left-hand cylinder head. This eye must be removed before taking off the cylinder head cover on the left-hand head. If you don't, the cover will snag. Something a bit unusual with the cover gaskets is that they're integral with the cover. Therefore, if one is damaged in some way, the complete cover has to be replaced. To avoid damaging them, make sure a cover you've removed is placed on the bench with the gaskets facing up. If you're going to disturb the camshaft positions, perhaps to replace the timing chain or to remove one or both cylinder heads, then once the spark plugs are right, set the engine to top dead center using the mark on the crankshaft damper. You can double-check this by the marks on the camshaft locking discs that should line up with the leading surfaces of the heads. The top chain guides on each head are simply held in place by a single bolt. Once these are off, you'll need to release the chain tensioner located at the front of the right-hand side of the right-hand cylinder head. This is done with an Allen key, turning the set screw clockwise. After which, the tensioner can be removed. Removing the camshaft sprockets requires some patience, make no mistake about it, particularly the one you should start with, notably the right-hand sprocket on the right-hand cylinder head. The job does get progressively easier. The first stage is to loosen both sprocket bolts. Then set each camshaft to a relaxed position. And you'll find this procedure is detailed in your workshop literature. The bolt to the right-hand sprocket can then be removed, together with its washer, and then the locking disc, and be careful none of these drop down into the chain chamber as you remove them. Before attempting to remove the sprocket itself, set the camshaft back by tapping it lightly. This will give you just enough clearance to release the sprocket from the camshaft and then work it free from the chain. It is a slightly difficult operation, so be patient. It certainly won't come free if you try to force it. Once it's removed, mark the sprocket clearly and keep it together with the washer, locking plate and bolt. And once this first one is removed, the others are easy enough because of the slack in the chain. But an important point to remember, you must maintain tension on the chain while the sprockets are being removed and once they are removed. The reason for this is to make sure the chain doesn't disengage from the crankshaft. It could be difficult to relocate it without removing the sump. Removal of the camshafts themselves is much the same as for any other engine. A point to note is that the bearing caps are marked. Numbers are used on the set on the right-hand cylinder head. Letters are used on the left, and your workshop literature details their precise positions. Even so, it's sensible to store the components in their correct order. There's a familiar special tool to be used for untightening the cylinder head bolts. And apart from a bit of muscle, it's a perfectly standard procedure and needs to be done in the order that is detailed in your workshop literature. With an aluminium head, it's particularly important to follow this order. And one unusual point. There's a 9th bolt in the chain chamber of each head, one that's easy to forget until you try to lift the head off. You must also, at this stage, remove the 2 chain guide bolts at the front of each head. At which point, you can call for some help and lift off the head. 2 pairs of hands are needed because you must try and keep the timing chain under tension so it doesn't drop off the crankshaft sprocket. Otherwise, the process is easy enough. Removal of the second cylinder head is achieved in exactly the same way. And you'll need to block off the crankshaft before trying to remove the crankshaft damper. Once this is done, undo the crankshaft damper bolt to remove it and its washer. You'll find that the back of the washer is coated with a sealing compound, which mustn't be forgotten when you reassemble. You now replace the damper bolt, but without its washer, and screw it into a point where it's still about 20 millimeters away from being fully seated. The reason for this is that the special tool you'll have to use to pull the damper off seats on this bolt. It expands inside the damper so that it grips and enables you to wind the damper off. This procedure is one you should know all about. The water pump is the same as on the standard V6 engine, but the oil pump drive is different. There's a special drive gear unit that fits where the distributor usually goes. It engages with the oil pump shaft and an intermediate shaft located where you'd normally find the camshaft. If you find it difficult to remove, you can use a slide hammer. The pistons are new, being graphite coated, each with 4 bells in the crown to accommodate the 4 valves per cylinder. The piston pins and the piston rings are also a new design. To remove the timing chain, the cylinder heads, sump and timing chain cover have to be removed. There's no other way. The only point to beware of with the timing chain cover is that there's a final bolt hiding in the recess of the V-shaped crankcase. Once all the bolts are out, the cover just lifts away. It's worth taking a quick look at the routing of the timing chain because its 2.2 meter length does wind a fairly circuitous path. From the crankshaft up the left side along the chain tensioner arm to the camshaft sprockets, back down to the intermediate shaft serving the oil pump, up again to the cam sprockets on the right, and finally back to the crank via an idler gear. What helps to keep it in place are the chain guides that are bolted into position. Apart from the points we've covered, dismantling of the rest of the engine is all pretty standard, and you'll find the procedure fully detailed in your workshop literature. Assembly of the Ford Cosworth V6 involves a few points that need to be remembered, a few points that require particular care, but in the main it all follows fairly logical steps. Any gaskets that are removed during dismantling any part of the engine must be automatically renewed. That's important, although no different from any other engine. After fitting the timing chain cover gasket, the chain guides can be fitted, and they simply bolt into position. Installing the timing chain is a job that must be done in a particular order. It's best to locate it first on the intermediate shaft sprocket. Then slot it into the upper chain guide. Down through the lower chain guide, leaving enough slack at the top to accommodate the camshaft sprockets. Then round the crankshaft sprocket And finally, lay it along the chain tensioner guide, which needs to be placed in position at the same time. This order of installation is important because if you start from the crankshaft sprocket and work up, you could find yourself getting in a bit of a mess with lots of chain hanging around where it shouldn't be. There are 2 points to remember about installing the timing chain cover. First of all, position it roughly with perhaps 2 bolts holding it in place. Then use an available special tool that's mentioned in your literature to centre the cover over the crankshaft spigot. As you tighten the cover bolts, keep checking that the cover lines up precisely with the crankcase at both the bottom and particularly the top. And finally, don't forget the 1 bolt that's hiding away. To refit the sump, you'll need a new gasket. Similarly, the crankshaft damper bolt and its O-ring can only be used once. They must be renewed after removal. And you'll have to coat the back of the thrust washer with sealing compound to prevent oil leaks. Installation of the damper is simple enough. You must remember, of course, to block the crankshaft so the damper bolt can be correctly torqued. With piston number 1 already near top dead centre, the engine must now be correctly set using the mark on the crankshaft damper. New cylinder head gaskets are a must. You'll find you have to cut the left-hand gasket, which is clearly marked. Subsequently, you must trim the edges to prevent the gasket from chafing and damaging the coolant hose that runs between the head and block. The 2 sections of the gasket fit independently of one another. This is not the case with the right-hand head gasket. When you fit the small gasket, once again make sure you maintain tension on the timing chain so it doesn't drop down. To fit the heads, guide dowels are an absolute must. And a point worth making here is that valve seats in the heads can be reworked in the usual way using existing cutting tools. And before you refit the heads, make sure the surfaces are clean and undamaged. Once again, you'll need some help to hold the timing chain as you wriggle the head into position. A complete new set of head bolts must be used because the old ones will have stretched. They are torqued into position in 2 stages. First, tighten them down to the torque given in your literature and in the order that's also detailed there. Then each bolt should be tightened a further 180 degrees, again using the order of tightening shown in the literature. And finally, don't overlook the 9th bolt that's located in the chain chamber. The use of hydraulic tappets means no valve clearance adjustment is needed. Should one fail in any way, they can be replaced individually. Each camshaft must be installed in its original location and be set to a relaxed position near its top dead centre, and this is detailed in your service literature. Don't forget to lift the timing chain over the cam spigots before you fit the bearing caps. You won't be able to do so once the caps are in position. The points to remember are that those bearing caps marked with letters fit the left-hand head in the order shown in your literature. Those with numbers are fitted to the right-hand head. And the fitting of that right-hand head follows precisely the same procedure except for the points about the gaskets and tightening sequences. And before you start to fit the camshaft sprockets, check again that the camshafts are set as shown in your workshop literature. Assembly of the camshaft sprockets and the location of the timing chain is fiddly. It's also critical because just one link out on a sprocket will totally destroy the engine's timing. With the thrust washer in place, the camshaft sprocket can be positioned with its crimp hole to the top and the chain tensioned round the sprocket. Then gently set the camshaft forward. As you fit the locking disc, align it with the flat on the cam spigot, align it with the flat on the cam spigot, and then turn the cam slightly so that the crimp on the locking plate engages with the crimp hole on the sprocket. At which point the fastening bolt and its washer can be screwed in finger tight. A final step is to line up the timing mark with the leading surface of the cylinder head and then move on to fit the second camshaft sprocket. Once both are in place, the securing bolts can be temporarily torqued. The procedure for installing the camshaft sprockets in the right-hand head is precisely similar. The point to appreciate being that installation of the final sprocket itself will be tricky. Patience is needed to get it absolutely right, because this is the point where it's possible to assemble the sprocket just one link out of alignment on the chain. But providing the timing marks on all 4 sprockets and on the crankshaft damper are correctly aligned, all should be well. Once all the cam sprockets are installed, you can fit the chain tensioner. Here, to set the chain under tension, you turn the set screw anti-clockwise using an Allen key. This is merely a reverse of the dismantling procedure. A final check to your timing should be to turn the engine over twice and then make sure that the timing marks are aligned correctly. If they are, you can finally torque the cam sprocket bolts to the level shown in your literature. At this point, refit the 2 chain guide bolts at the front of the cylinder heads. And also the 2 small covers. The top chain guides can be bolted into position. And when you come to fit the cam covers, run a final check on those integral gaskets, just to make absolutely sure there's no damage. A small but important point about spark plugs. You'll need a magnetized socket to remove and install. And because they're set so deep into the head, take care not to cross a thread. An aluminium head damages very easily. None of the final items to be assembled present any difficulty. It's more a question of getting things in the right order, although the wiring loom can go below or above the thermostat housing. As to the thermostat housing, don't forget that the spacer tube that connects it to the left-hand cylinder head will need new O-rings before it's installed. A useful hint to help install the water hose that runs between the left-hand head and cylinder block: a bit of soap will make it easier to wriggle the hose into position. It is quite a tight fit. New O-rings will also be needed when you refit the top heater pipe running from the thermostat. A final point that requires special attention: when you come to fit the oil cooler, it needs to be positioned so that its hose connections point downwards and approximately 20 degrees to the rear of the engine. This ensures that the connecting hoses will match. Installation of the oil filter is easy enough, but should best be done after fitting the engine into the car. Apart from these points, assembly of the remainder of the engine follows a predictable path and is fully detailed in your literature. The air intake, fuel injection and engine management systems have a number of interesting new features we'll deal with in this final part of the programme. But before doing so, it's worth noting the neatness with which this Ford Cosworth V6 has been installed. For the owner lifting the bonnet, it's a gratifying sight. For you in the workshop, be assured the various covers are easily removed for service work. Among the new features on the air intake system is a new type of air mass meter that precisely measures the flow of air into the engine. In effect, it's a heated element positioned in the air stream close to the air filter. In operation, it's programmed to be kept at a defined temperature. As air flows past the element, so it tends to cool, and so more current is required to maintain its temperature. As the airflow reduces, less current is required. This variation in current is monitored by the EEC4 module to read minute variations in the volume of air being drawn into the engine. Not only is the system highly effective, it's also highly efficient and needs no service attention. The throttle housing includes progressive twin throttle plates. Under light throttle, the smaller plate opens. As acceleration increases, the larger plate opens. These throttle positions are monitored by the throttle position sensor that signals the precise positions to the EEC4 module. A component you'll recognize is the idle speed control valve. Controlled by EEC4, it allows a limited air bypass when the throttle plates are closed. And should you need to remove the air plenum chamber, note that it's secured by 6 nuts and that the one to the front of the chamber has an integral gasket. The bore for this stud passes straight through the chamber, and this gasket prevents any air leaks. When you do remove the chamber, a small point, disconnect and then block the EGR inlet pipe away from the chamber, otherwise it snags. The EGR valve itself is located beside the right-hand cylinder head. With the plenum chamber removed, you'll see that the fuel rail is a new design with its pressure regulator bolted to the side. As mentioned earlier in the programme, the multi-point fuel injection system is banked, with EEC4 controlling the volume of fuel injected to each cylinder. The new engine's ignition system is distributorless, known as eDIS-6. In operation, this is exactly the same as the familiar eDIS-4, but with the addition of 2 cylinders to the circuitry. As on eDIS-4, 2 cylinders are fired simultaneously. The high-tension leads to the spark plugs are neatly routed beneath a plastic cover, which has to be removed to reach the connectors and plugs. The only point on spark plugs is to remember to use a magnetized socket and be careful about removal and replacement. A final point concerns the crankshaft position sensor. On this new V6, it's located at the front of the engine. Its job is to detect and signal the precise speed and position of the crank to the EEC4 module, and it can't be adjusted in service. This EEC4 module, positioned inside the car as usual on Scorpio, has a much increased capacity that brings a particular service benefit in the form of its extended self-test capability. A new 3-digit star tester has been developed, which must be used on this vehicle to take advantage of that capability. The procedures for use are precisely the same as on the standard 2.9-litre V6 vehicles, and test codes are contained in your test manual. Apart from these few service points, you'll find most other work precisely as for the standard Granada Scorpio vehicles, using exactly the same equipment. There are only 3 new special tools that are either new or adapted from existing tools. They are for removal and installation of valve springs to replace the valve stem seals. All in all, for such an advanced engine, its service requirement is remarkably straightforward. A feature that should please all who are faced with this new Ford Cosworth unit in the workshop.